Welcome to today's mini lecture. Today we are going to talk about the 5 different types of reactions. What's really cool about chemistry is that even though you have hundreds and hundreds of different examples of chemical reactions, there's only 5 chemical reactions. So we're going to learn how to identify these 5, but also we're going to also know that if you can identify the type of reaction, it'll tell you how to balance the reaction. So I noticed in yesterday's class that a lot of people were having trouble with a couple of the more difficult reactions to balance, and y'all were like, well, how do you know where to start? Do you just guess? And a lot of that is true, but there are certain trends that you can follow. But before we start doing that, we have to make sure that we can identify the 5 different types of reactions. So the way that I teach them is I teach them as opposites of one another, or kind of together. Like if you look at the first reaction, this is called a synthesis reaction, and this is called a decomposition reaction. Now, if you were to look in your resource packet, on page 6, you can see that it gives you the different types of reactions. So here we have the synthesis, decomposition, single replacement, all the way through. So that resource packet is where I'm getting this information from. So first of all, the word synthesize, that means to build up or to make. So what we're doing is we're adding elements or compounds together to form one larger compound, one larger substance. And if you look at this, do you see how it's divided by an addition sign? So that's 1 plus 1, and they combine together to make that one product. So I have 2 reactants making one product. They synthesize, they build up. Now the reason I say it's the opposite, the next reaction is opposite of that, is because decomposition means that it breaks down. So what's going to happen in a decomposition reaction is you're going to start with 1 reactant, and that 1 reactant will break down into 2 or more products. And if I look, we have a silver oxide, 1 reactant, and then it breaks down into, in this case, 2 of the products. So if it's breaking down, then it is going to be a decomposition. Come back up here to single replacement. A single replacement reaction is exactly that. You have a single element and you're adding it to a compound. So do you see how I have the single element of aluminum, and I'm going to add that to the compound hydrochloric acid, or HCl. So I have a compound here and I have 1 element. Well, that single replacement means that that 1 element is going to replace 1 element from the compound. Now, I know that aluminum is positive, and I know that hydrogen is positive. So the positives are going to trade places, and that leaves me aluminum chloride, which is an ionic compound, positive aluminum with a negative chlorine, and now I have the other free element, or my other single element being released. So it starts with 1 and a compound and ends up with 1 and a compound. That's a single replacement. Now, the double replacement, they're probably the easiest to identify because they are so big. And when I say big, I mean literally it is a compound plus another compound, and then you're going to get a compound plus another compound. So when I say big, I mean literally they're going to be written out pretty big. It's a compound plus a compound, compound plus a compound. No free elements present. And then finally, we have the 5th one, which is called a combustion. Combustion means to burn. So if you're burning a candle or a piece of paper or wood, then this is the type of reaction that's happening. We have a hydrocarbon, hydrogen and carbons, and that hydrocarbon is going to be added to oxygen. We know that in order for anything to burn, oxygen has to be present. And then whenever it burns, I'm not worrying about the heat that's given off. I'm not worrying about the heat energy. I'm looking at what's going to happen to the chemical compounds. I'm going to get CO2, which is carbon dioxide, plus water. I always get somebody says, you mean when you burn something, you're creating water? The answer is yes. But what happens is it's such a small amount of water compared to the amount of energy of that burning out, oxidizing, that water automatically is going to be vaporized into steam. So you're not going to see it start dripping or anything like that. So these are our 5 different types of reactions. So what we're going to do is now I'm going to go back and just simply say, hey, if you know that you have 5 different reactions, if you can identify it, it tells you where to start to try to balance it. Let me give you an example. So if I start with a synthesis reaction right here, then I know wherever that 1 is, you see how I have 1 product? I can start right there trying to balance it. So whenever I look at this, I have 1 sodium, I have 2 sodiums. I have 2 oxygens, I have 2 oxygens. So my oxygens are going to be already balanced, so I have to balance my sodium. So I'm going to leave a 1 right there, just come over here and put a 2, and it's balanced. So it actually balances with a 2, 1, 1. So now let's look at the decomposition. Decomposition, always say it's exactly the opposite. So what's going to end up happening is I'm going to start where there's 1. I have 1 reactant. So this is where I'm going to start. So my teeter-totter says 2 AGs, 1 AG, 1 oxygen, 2 oxygens. So where do I go with this? I'm going to have to put a 2 right there. That now gives me 2 oxygens and 2 oxygens. It gives me 4 silvers, so I'm going to have to put a 4 right there. So it balances with a 2-4-1 ratio. Single replacements, like synthesis and decomposition, you always start with the 1 compound. With single replacement, you always use just straight up teeter-totter. So if I look at this one, it's 1 Al, 1 Al, 1 H, 2 H, 1 Cl, 3 Cls. So I would probably want to start with my Cls. So I'm going to put a 3 right here. So now I have 3 chlorines, 3 chlorines. Now I have 3 hydrogens, 2 hydrogens. Is there anything that I can multiply by 2 to get 3? And the answer is no, there isn't. So I don't give up. I use a pencil and just erase, and it did not work with a 1 right here. So I'm going to put a 2 right here. Now we'll stay with my chlorines. I've got 2 Cls and 3. That's 6 chlorines. So I'm going to have to put a 6 right here. Now I have 6 hydrogens. I can put a 3 right here. I have 2 aluminums, so I can put a 2 right there. So it's all about being able to figure out where to start. And that's exactly what we're doing whenever we determine the type of reaction. Last one is the next one is a double replacement. So when I do this one, again, it's just that teeter-totter. It doesn't matter. I just have to look and see where it's not balanced. So I have a Ba here, a Ba here. I have a polyatomic here, but it doesn't occur over here. So I'm going to have to look at it as 2 oxygens and 2 hydrogens. Look at this. We've got a hydrogen here. So I've got those 2 plus these 3. So 5 hydrogens in all. This polyatomic PO4 does appear on both sides. So I'm going to leave the PO4 on both sides. So where is it not going to be balanced? And that's going to be this oxygen and this hydrogen. So which one do I start with, oxygen or hydrogen? Well, this is called a split element. Do you see how it appears here, plus over here? And same thing on this side, here, plus over here. I never want to start with my split elements. If you have any opportunities to start anywhere else, always choose to come back to those. So I'm going to start with my oxygen. I have 2 oxygens. Now I'm not worried about the PO4 and the PO4. I'm worried about this one. So I'm going to put a 2 right here. My oxygens are now going to be balanced. Look at my hydrogens. I got 4 plus 1, 5. I've got 3 plus 2. It balanced itself out. That's what you're going to find will happen most of the time. If you know where to start, you can slowly go teeter, totter, and all of a sudden you're like, hey, it's balanced. And that's exactly what happens. The last type of reaction is a combustion reaction. So in this one, you can see I have C3H8 plus O2. I always want to do carbons, hydrogens, split oxygens. So my carbon is 3, so I'm going to put a 3 right here. My hydrogens, I have 8, so I'm going to put a 4, a 4 right here. Now my oxygens, I have 3 times 2 is 6, plus 4 is 10, so I can put a 5 right here. So it's a 1, 5, 3, 4 ratio. Make sure I got that 6. Yeah, that looks good. So I know that was quite a bit to kind of throw at you all at one time, not just the 5 types, but how you use those 5 types to start balancing. So what we're going to do next in today's assignment is we're just going to go back in and we're going to identify the 1 through 20 that we did yesterday. And we're just going to say the type of reaction. There's going to be a couple of them on there that you probably had trouble with, but now, once you know this, you should know where to start. So if you have any problems with that, just say, Mr. Vance, I'm still having problems with number 17. Where do I start? And I'll say, well, it's just like this. It's a decomposition reaction, so you always start with the 1 reactant, and you go a 1, a 2, a 3, or a 4, and it'll balance out. So that's what we're going to do. And then in tomorrow's class, what we'll do is I'll give you another practice set so that you can go through looking at, and I'll give you a copy of these rules that I just went over, and you can go through and look and see how you apply everything. So I hope that this mini lecture helped you. And again, we needed to learn how to identify the 5 types of reactions and then use those to make sure that we know where to start when we're trying to balance them.